NEXRAD weather control. Effect of cooling towers on the atmosphere and weather. For some time now, I have made it very clear, in spite of incessant suppression and disinformation resistance, water vapor generation is, by far, the largest component of global geoengineering. Here are some of the primary components of geoengineering. 1. Global sequential in-place water vapor generation. 2. Global frequency control via NEXRAD, Doppler, and phased array grid. And 3. Global chemtrail program. Frequency controllable components. This sequential water vapor generation originates from the global power grid cooling towers and wet surface air coolers, as I illustrate in almost every video I produce. The fact that the scientific community has known for 50 years about the effects of cooling towers on the atmosphere and the weather, and their potential geoengineering application, is definitively proven in this 1971 study at Zion Nuclear Power Plant. Introduction. 1971. Because of ecological considerations, controversy presently exists over the use of Lake Michigan and other natural water bodies for the discharge of waste heat from large electric power plants, now under construction or planned for the near future. This problem has become especially acute in the case of a 2,200 megawatt nuclear power plant of the Commonwealth Edison Company, now nearing completion at Zion, located on Lake Michigan in the northeastern part of the state. This plant was designed for once-through cooling, utilizing lake discharge of the waste heat, but this method of cooling has met opposition from several sources. An alternative method of solving the thermal pollution problem is through the use of large cooling towers, which dissipate the huge quantities of waste heat directly into the atmosphere. However, this alternative then raises concern about the environmental consequences of the effluent discharged into the atmosphere from the towers. Results of literature review, 1971. Basically, the literature search revealed a discouraging lack of information on how effluents from large cooling towers, such as those which would be required at Zion, affect atmospheric conditions in their vicinity. Research with respect to this problem has been hampered by the lack of well-organized and properly conducted field studies to collect the meteorological data necessary to promote and accelerate needed research. The literature review revealed a discouraging lack of well-organized measurement programs and research upon which to assess reliably the meteorological consequences of large cooling tower effluents. Furthermore, this problem is rapidly becoming more critical as the electrical power industry continues its rapid growth and ecological objections to once-through cooling increase. Only a very limited number of research and field studies have been conducted to date on the meteorological aspects of thermal pollution, and these have been in conjunction with studies related to biological processes rather than atmospheric effects. All evaluations have been made assuming the operation of 2 generating units with a total heat load for cooling equipment of 14.3 times 109 BTU per hour. The required evaporation in cooling towers will average 18,000 gallons per minute. Moist tower plumes can initiate cloud formation. In their studies at Keystone, Pennsylvania, Visbicki et al. 1970 find that tower plumes will contribute to local cloud formations at times in varying degrees, depending on atmospheric conditions. Carson 1970 states that the extra heat and water vapor from cooling towers may create cumulus clouds, and that the possibility of tower plumes acting as a trigger to produce extra cumulus congestus clouds and precipitation miles downwind of the release must be considered. Tower plumes can be seen to evaporate and then recondense to some extent at higher altitudes, further downwind. The plumes will persist after leveling off and appearing downwind as stratus cloud coverage, or merge and reinforce existing cloud coverage. From climatological observations and cloud physics research, it is known that Cumulus clouds and rain showers or thunderstorms can be triggered by relatively small inputs of energy. As an example, Changman, 1968, has shown that areas downwind of Chicago have experienced 20 to 40% increases in precipitation due to urban industrial effects. Hence, the possibility that cooling tower effluents could modify the rainfall distribution on a localized scale must be considered. Severe thunderstorms and even tornadoes can be caused in very unstable weather situations by dry and clean heat emission. It is quite evident that any severe weather event resulting from cooling tower effluents could be attained only through a triggering or stimulation effect. That is, the additional heat and or moisture fed into a developing storm cloud could conceivably produce an imbalance that would result in its intensification into a severe weather state. The scientific and engineering professions do not now have either the information or the experience necessary even to begin operational avoidance or reduction of the fogging problem which we know exists in connection with industrial cooling tower and pond facilities. Dr. William P. Lowry, Oregon State University. Clearly, a firm understanding of environmental modification by cooling towers will have to be established by proper measurements in the vicinity of operational towers in order to validate and refine the theoretical concepts. EG&G Incorporated. Besides proper meteorological measurements, ecological monitoring will also be necessary to evaluate the total influence of the tower effluents on the environment. EG&G Incorporated. In conclusion, it can be stated that there are a number of effects, mechanisms, and interactions occurring both with cooling tower plumes and tower plumes mixed with nearby stack emissions, the problem appearing more complex than was initially thought. Dr. Eric Ainsley, IIT Research Institute. Meteorologists don't know how the atmosphere will react quantitatively to the large amounts of heat energy and water vapor that it will be forced to absorb as a result of waste heat from nuclear power plants. Dr. James E. Carson, Argonne National Laboratory. Extensive measurement and research programs must be carried out to obtain the needed knowledge. The time to do this is now, not in 1980 or later, when the problems, whatever they may be, associated with cooling tower effluents will have increased many times with the rapidly increasing demands for electrical power. 50 years later, the world we live in proves what happened. The serious weather effects that would have resulted from two cooling towers at the Zion plant, that prevented their construction entirely, were subsequently suppressed, marginalized, and ultimately dismissed, at least as far as any public dialogue is concerned. How do we know this? Because the known weather effects from two towers that were too great to build them were not even a public consideration, as these towers were rolled out to most of the 7,000 power plants across the country, or the 62,500 power plants across this planet. The feared weather effects from two towers in 1971 now exist in reality an absolute minimum of 62,500 times over. Many tower farms are larger than anyone in 1971 would have conceived of. For example, if we use the same numbers as Zion, 18,000 gallons per minute times 2 hours equals 2,160,000 gallons. Two towers per station equal 4,320,000 gallons, times 7,000 U.S. plants equals 30,240,000,000 gallons, times 62,500 power plants equals 270 billion gallons. That's 270 billion gallons of water vapor added to the atmosphere from just 2 hours of tower operation from each station, and that number is preposterously low. The towers rejected at Zion used 18,000 gallons per minute. The towers rejected at Indian Point used 700,000 gallons per minute. It's not up for debate whether this is happening or not. I watch it every single day, and so can anybody else who is remotely paying attention.
A couple questions here about HAARP. the High Frequency Active Auroral Research Program. I'm told by the president of the University of Alaska that the Air Force has pulled its support for the facility, and they're taking steps to demolish it or take it down this summer. So the question to you is that accurate? Can you explain why?
The Air Force has gotten great value out of HAARP in the past. We took over from the Navy and managed it and actually did a number of experiment campaigns up there and have finished our work that we're interested in doing up there. We've moving on to other ways of managing the ionosphere, which the HAARP was really designed to do, was to inject energy into the ionosphere to be able to actually control it. We have put out a call government-wide for other agencies that had interest in managing the site or taking it over, and including going out to academia. We have gotten interest from the university in Fairbanks. However, the interest we have is that they will run it if we fund it. So our position has been that if there's not somebody who wants to take over the management and the funding of the site, then the Air Force has no future need, and that we do plan to do a dismantle of the system in the future after we make appropriate notifications.
Yet there isn't so much as a peep from any so-called geoengineering activist, climatologist, meteorologist, etc. about this ceaseless and massive sequential source of heat and water vapor in the atmosphere for the last 50 years. All there is in the PSYOP co-opted activist community is more SOP misdirection and offensive denial.